Right, so this video is going to go through the basics of how to do Lab 4 for the Biometrics voice recognition section. So what it is really is to isolate, analyze, identify voice prints and formants, just like we did in the lecture today. So basically the thing that we need to do is do some recordings and take some readings and analyze them in a particular way to answer all the questions that are laid out here, including display the results in a particular table format with actual numbers and answer the following questions at the end. Right, so let's get straight down to it. Here's a sort of a basic sample that I'm building up. So to analyze and compare the formal values of the spoken utterance for a variety of speakers, that's what we're trying to do. Who did you choose your speakers for? So recordings in this case are made for subject A, subject B, and subject C. So just write down what it is, if it's like an adult male Irish accent, whatever the region is, or adult male US accent, for example, if you've taken somebody offline. So these are the phonemes we want to basically get. So she just had bad, etc. Now I'm just going to look at one for now. We'll just take this kind of had phoneme in greater detail and that we want to look at. So phoneme 1, AA1, had, you might just write that down phonetically if you wish to be very clear on what exactly it is that you're looking for, mainly for your own reference later when you look back at this. So let's just get straight down to it. We'll see the recordings that I've made right here. Okay, so here's the first recording. I'll just go and show you that in the standard view so we can look at that in Waveform View. I'll play it for you right now.
And I had a choice to make very early on. Okay,
so I don't know if you recognize who that speaker is, but he's a famous guy. And we'll zoom in on that word had that he says. He says, I had a choice to make very early on.
And I had a choice to make very early. And I had a choice to make very early on.
Right, so he says that syllable roughly around here. Had. Here more so. Zoom, he says it very fast. Okay, so he says I had a choice to make very early on. We'll zoom in, keep it there, and just look at it, you know, and keep that in mind for a second. And what you want to do to get the actual picture of that, the formants of that, is just to really be clear on what you're isolating. So just isolate the A part, so you can see the pattern in there. This is the H part, and there's the D. He does say it very, very fast, but you can literally see the pattern emerging there. So don't be careful not to take too much. If you want to be extra sure, just check on the spectrogram view, and you can see there the actual numbers are in there. So you can see the numbers are appearing there. So we'll just do analyze and plot spectrum, and we can see it there. Okay, so when I look at that, you can see that the numbers are very specific, and there his first formant is 175 hertz. Okay, it's 175 hertz. Just keep your eye on the number changing as you scroll the cursor to the peak. There is the second formant, and you can see that the second formant is just kind of building up towards its peak, and these are just sort of harmonics as the second formant dissipates. So what we can do is write those numbers down. I suggest we take a screenshot of each one as well as you're at it, as you're actually asked to do in the particular lab. So I just kind of close that screenshot there. We can pull that up, and I'll make it into something usable. So just kind of do that again. There we go. That's a bit more like it. Just take that up there like so, and we can cut that out and just show it, and paste it right into our table. Okay, so there's our table here. Then I'm doing up, and we can see that that's the speaker C, Donald, adult male US accent, New York region. So we'll just pop his information here. So his subject C, it is not synthesized, it's the AA1 phoneme we're dealing with, which is the A of had. I'll just chop out those example. Those are the samples that we dealt with earlier. So leave those. We want to get rid of those. I just copied that down really from the actual the actual brief. So I'll just put the picture in there. It's easy enough to make this smaller. I suggest you just keep them in the table and try to make them smaller, mainly for your own benefit. In fact, actually, you know what you probably should do is you should annotate them. Just annotate them with the numbers in the specific place. So we'll just put a little kind of a circle in yellow around where we know that the peak is. So there's that first peak and there's that second peak there. So that first peak, look at it again and just check what it said. The first peak was 173 hertz. The second peak was 614 hertz. So 173 and 614. So 173 hertz. Just indicate that on your diagram to annotate it, and 614 hertz. Okay, so that's probably good to go there. And we'll just double check it again to make sure we've got the numbers right. So 173 roughly and 614. Okay, so you can see there's a major peak there. It's building up. That's the highest peak, and it sort of drops a little bit. This one builds up to be the second formant, and these are literally just that second formant just dissipating. So we only have two major formants on this particular reading here. So we can just put those into the diagram as such. So I'll just pop that in there under subject C. And just copy it. I'll copy it again from here and put it there under subject C. Okay. Just make it a little bit smaller. I can always increase the size in the PDF format to get a look at it. So that looks pretty nice there. That's kind of clear. You don't need to have it huge, and you don't want to make it too small either. But like, you know, I can read that. If you increase the size of that in your PDF file, we can read what those values are also. It's not that really tricky to see it. Okay, so something like that would be one reading. So basically, for every reading, we want to put in the screenshot. So that's subject C's reading. You can see it there. He got 173 hertz for his formant 1 of the A sound and had. The second formant he got was 614 hertz for that same reading there. So there he is. That's your first reading done. Subject C, this is Donald saying had 173 and hertz and 614. Okay, so I'll just kind of save that and we'll move on to the second one to do that one.
For those who've lost their jobs and had their income. For those who've lost their jobs
and had their income.
So
that's the had that we want to isolate. So this is grab it here. It's about here roughly.
Had.
Okay, so you can see the had, the difference between the huh sound. There's huh. There's the end of the had, the duh sound. Okay, we want that middle isolated vowel, and you can see, even though he's speaking fast, it's a nice clear pattern that you've got there. So there's the a sound of had. Okay, had, add, a sound. You can see it in the spectrogram. Probably want to tighten it a little bit more. You can see the kind of a coming up with the white when you look at the spectrogram view. Okay, that's a little bit better. So you can see there's the formants that we're looking for there. Let's check if they're similar to the first politicians. So plot spectrum, and there's the picture is very, very similar. So the first peak is roughly around here. You can see it's like roughly 100 hertz, I would say. I probably didn't isolate it. I isolated it a little bit too much. Let's just do more of that to get the full range of a. Okay, so we can see more data to work with, and there you go. It's the same again. It's roughly 100. The first one is, and the second one is there, but 700 hertz. And you can see there's a very clear. This is what I'm calling in the labs a sort of an Irish peak. It's an Irish hill. The peak is not really obvious, but it's there. That's the first peak, and it's going down up to the second formant, and these are just really just harmonics, they're dissipations of that first formant. So they're not important. So let's just mark that there. That's 96, and that one is 704. So for this subject, Leo, adult male, we will mark his first one as 96 hertz, and mark it again. Just check it, check it each time there when you're writing it. Just be absolutely certain that you're getting the right data. So it's 96 and 704 hertz. Okay, so 704 hertz. Okay, so there is no third formant, so just leave that blank. Okay, and we can then proceed to take that out and that's my one. We'll take this Leo speech rather. Take that and just mark it. Okay, so double check again that you've got the numbers correct. So you've got 96 and a 704. We'll do a print screen on that and go ahead into the box, and this is really the pattern we're looking for. So it's not just a case of doing 6 of them for no reason. We're looking for a pattern here. So you might be thinking, I'll switch off this video and I'll just repeat that 10 times. There's a pattern that you want to look for within this. It's really the idea being that we find some type of a pattern which indicates a way we can guess in advance what these values will be. So do go and mark them in there, because it's good for you to just do this in your own kind of learning and looking back at a later stage. So these numbers are easy to forget, so just keep a record of them so you can see where they are both in your document and also in this diagram. So 704 hertz. Okay, so there's no need to save files or anything like that. You can just take the one picture and just take that, copy it, place it down into the file like so. So here's subject A, 96, 704, and decrease that in size, make it a nice fit in there, and that's the second one done. Okay, so I'm not going to do every one, I'll just do the third one, and I'll do the synthesized one to compare. So I'll just do really this one phoneme here. I don't want this video going on too long. So that's it there basically. Then so that's the second one done. All right, so subject A has 96 hertz for the first formant, 704 hertz for the second. Subject C has 173 hertz and 614, kind of similar ranges, roughly the sort of 100 to 170 range, the sort of 600 to 700 range. So even the two pictures, you can see there's the A of subject C, there's the A of subject A. So let's take another subject. This is the one I recorded myself. This is me saying the same thing, and I just recorded that. I'll play it again. So
she just had a toy boyfriend. It's sad.
All right. So hopefully I'm not a politician, but let's get.
She just had a toy boyfriend. It's sad.
Okay, so we're isolating that same word. We want to isolate that word had in the same fashion as we did the others. Okay, so here's the view. That's coming out quite clear as well. So the waveform view DB, you can see the pattern. So don't kind of go for the h part, because you'll end up destroying the okay, or the d part, because these are fricatives, like we said. Okay, they're the fricatives which aren't going to really help you. Okay, go for the open, clear vowel sound. So just going to go inwards and leave a bit of space that that the vowel pattern is there, so you're not cutting in anything else. Okay, so I think just a little bit less there. Okay, so there we go. So we can look at that in the spectrum view again to be sure. So you can see we're just isolating what the formants we want. These are the formants of the particular phoneme A in had. So analyze, plot spectrum, and again, there's a new picture. It's pattern emerging. It looks very similar to the other two. So the first one we'll say is 147. The second one is roughly 747. And be sure to use log frequency rather than linear frequency, because you'll get a better picture of a representation of the same data. So 147 for the first peak. 147, 145. It goes down, goes up to the second peak, and that is 747. Okay, so easy to remember, and the kind of harmonics in the second peak dies down. So we'll write them into the thing. So this is my one then. So it's basically the first formant that I got was 17 hertz. 17 hertz. And the second formant is 747 hertz. Okay, 747 hertz. And we'll put a picture. There is no third formant, so just leave that blank. Again, the picture's emerging. Look at that. And very similar to the first one. Okay, and look, that was the one with the Dublin accent. So subject A, mature adult Irish male with Dublin accent. Subject B, mature adult Irish male. Subject C, mature American accent. Okay, it's a difference. If that was a child accent, it could be different. If it was a female accent, it might be different again. But you can see the closest two formants in that picture are the two adult males with the Dublin accents. Okay, so I'll just print that screen again and put that in there. And there we go. Just do a little bit of minor editing on it just to kind of get the formants written in. It's always a very good idea to have this as annotated as possible for yourself, if nothing else. Okay, so 147 hertz. So that's a nice professional way to work. You know, it gives you a nice document at the end of it where everything is actually, you know, citable and your data is clear. There's no ambiguity about where you got your data from. All right, so just kind of print screening, just giving a print screen of it and saying like, you know, here you go. Well, that does, if you just do a print screen and just don't write it like anything in, like, you know, upload 5 screenshots. Well, that says two things. It says that the reader you're putting the onus on the reader to find the data and they've got to look at it. It also says that, you know, it's unclear. You haven't got a document for yourself to look back at a later stage. And that's what you want. You want to have it done in a sort of archivable format. I know it sounds a bit tedious, but at this level of your academic career, that's the sort of things we need to be thinking of, about archiving things in that professional manner. So let's put that in there. We can see it there. And that's the third one. Third picture. And you can see they look very similar. All three look very, very similar. Okay, so when we look at them again, you can see there's all of them. The adult Irish male, adult Irish male voice with the same accent, with the Dublin accent, and they're coming out fairly similar numbers. You've got that 147, 747 in my case, 96 hertz, 704 hertz in the other similar voices case. The US accent, the New York accent is slightly different. It's coming up there 173 hertz, 614 hertz. But, you know, the general ranges are the same. You're not getting a formant that's like, you're not getting 3 formants, or you're not getting like 2 formants up at the 1000 range and 900, which you might for a different phoneme voice sound. Okay, so that's the first 3 done. Let's move on to the last one, which in this case is going to be a synthesized voice. All right, so you're asked actually to look at some synthesized tools to get that information in there, and you know, I give you two decent websites to do that with. There's text-to-speech.org and there's voicegenerator.io. These are very good. Voice Generator gives some really natural sounding stuff. Like, listen to this.
She just had a bad toy boyfriend. It's sad.
Okay, it's pretty decent. You got a good choice there. There's even an Irish one in that. There's Sean English in Irish accent.
She just had a bad toy boyfriend. It's sad.
Okay, so there's a lot of these ones we can look at. You can download anything you like. So I'm just going to take a look at one of them very quickly here. So let's get the one that sounded pretty natural. So I think Mia, the UK voice, sounded pretty good. Let's try and play hers back.
She just had a bad toy boyfriend. It's sad.
Okay, that's a good example there. That's a good example of a synthesized voice.
She just had a bad toy boyfriend. It's sad.
Sounds pretty natural. Sounds pretty good. And let's look at the had.
She just had a bad toy boy.
I suspect that had is probably going to be very close to the ones we've already looked at, because it just sounds pretty decent. We'll see. It's a female voice, so the range is probably going to be higher. Had, so there's a had. Let's take a look at it in decibel view, so we see a little bit clearer. So nice clear pattern there. It's hard to even tell that it's synthesized looking at it like this. Okay. If you look at that in the spectrogram view, probably the only way you can be sure that it's synthesized. Okay, you can see that that spectrogram view. There's a lot of cut and pasting going on. There's harmonics missing all over the place really there. Okay, so let's go back to the waveform decibels, to our HAD. Here we are again. We'll analyze that spectrum, plot that spectrum. Okay, so what have we got here? So slightly higher, just kind of what I expected. So we have something 200, and that's the first formant there. That's the first formant, okay? And this is not the second formant here. It's sort of, you can sort of see it leads up. Like it sort of leads up to the picture. You know, there's the first formant there, the first powerful formant there, the strongest one in it. And the rest of them just going to lead up to the next one down. Okay, so we'll have a look at those numbers so we can see she's getting 214 hertz, and this would be her second formant, not this. This is building up to it, and this is winding down from it. So this is the next peak, and that is 692. So she's got 212 and a 212. Let's just mark these down while I'm kind of remembering it. So hers is subject D is synthesized 212 hertz, 212 hertz, and 212 hertz. The second thing there she has is the this one here. Okay, so 668 hertz. About that, 668, 666, 692, 692, is it 668? Right, so I'm seeing that by just moving the cursor over it. 668 hertz. So we'll take that photograph of that, take a screenshot of it, and conclude that also into the documents. So it's for future reference for yourself more than anything else, as well as the reader. You know, it's very important in academic writing to provide all information. You know, you do not want to just have your reader wondering where is something from. Where did you get that data from? Why does your data say this or say that? You know, prove it, show it. Like, you know, the onus is on you, the writer, to do that, not on the reader to sort of be able to be so clever that they can see it. So that's one of the reasons in this module that I want to kind of get you into that style of working like that, so you can see these things happening. So let's go back to those numbers. You know, they're easy to forget, but to manage them. So 212 hertz, and then this is Mia, the synthesized Mia. That does sound pretty natural. 668 hertz. That's her second one. So we'll put that back. Okay. So 668 hertz there. Okay. I might just drop down ever so slightly so you can kind of there, just put it like that maybe. You can even do a little arrow or something like that to sort of indicate where it's leading from, okay? Just so the user knows what it is exactly to be looking for. You know, like it's a good practice, because I'll tell you what, you get quick at this. You get quick at doing documents and doing citations, and when it comes time to do the thesis, you want to be at that phase where you know, you can put all your data in where it should be, and it saves you having, as you do it, if you just do it as you go, it saves you having to do it later on. Okay, so there's the third one we'll do. So I've taken basically 4 readings there, 4 phoneme readings. We'll put that in there. This one is synthesized, yes, and I'm going to add this person as our sort of subject number D, and okay, let's just wind that down. So there's really our 4 subjects, nice and clear. Good presentation. If you can keep that presentation just like that, everything is clear. Subject A, adult male, you know, the numbers that we had. Subject B, adult male. Subject C, adult male with a different accent. Now, subject D, adult female, and it's a UK accent. So I'm just going to, you know, put her down. I didn't want to do it until we had a few tests, but I think that's the most natural sounding one that I got, and I got that from this website, from Voice Generator. So voicegenerator.io, that's Mia. That's Mia, Microsoft Mia.
She just had a bad toy boyfriend. It's sad.
Okay, that's pretty decent. Those are good websites there. The women on that website sound good, but it's just because, like I said in the lecture, the range of
She
frequencies.
just had a bad toy boyfriend. It's sad.
Okay, even the Australian accent there, you hear that?
She just had a bad toy boyfriend. It's sad.
Okay, whereas the male accents won't sound that great because there's just a fewer range, less range. Here's George, supposed to be get that received pronunciation, but it just doesn't sound very natural.
She just had a bad toy boyfriend. It's sad.
Okay, so the higher range has more frequencies you can place in there essentially. Okay, so there's subject D. So we'll call that is Mia. We'll just say, this is how you should write it. So subject D, Mia, adult female, UK accent, received pronunciation, synthesized. Great. So there's your 4 subjects, all saying the same phoneme, had, phonetic spelling, had. Phoneme 1, you can do phoneme 2 yourself. I'm not going to go, you don't need to watch me do all of that again for a different one. Okay, so there's just one reason I'm doing this. We're trying to build up a pattern. So here's the results. So subject A, not synthesized, that's the Leo Taoiseach speech there. So 96 and 704. It's marked there for the A sound. There's mine. I get 147, 747, and that's kind of expected that they're so similar because we have the same accent. Okay, the US accent, the New York accent from Donald Trump, is kind of different. You can even see the pattern. Look at the pattern. Okay, he gets a bit of a peak here. Okay, it's slightly different. I know he was speaking fast, but Varadkar's speech was just as fast as well. So his peak there is slightly different. It's 173 and 614, slightly kind of different, but still in the range. Like I say, he's not getting formants of like 2000 or anything, or 1500 or something like that, or in the 500 range. That would be a very different picture otherwise. Okay, subject set of D. This is the female accent. Again, slightly different. The 212 hertz is slightly higher. I was expecting this. I would have expected that to be slightly higher as well. Generally speaking, I would have expected the both formants to be sort of up there as one kind of octave higher, really, like, in both instances. But you're getting a bit of a pattern emerging here. If we do enough of these, we'll see it. Just to be really clear, by the way, when you're doing these, when we're doing these things, I'll just do a kind of a highlighter situation. You can see what's happening. I mean, there's the peak sort of builds up. The peak just builds up. The peak builds up there and then comes down. Like, it's almost like a stock market. Sort of stocks rise, reach a peak, and then they fall. That's what's happening here to that formant. That formant rises, reaches its peak, and then it falls. Okay, that's exactly the same for all of them. If we look at any of those pictures, we can see they sort of rise, reach a peak, fall, rise, reach a peak, and then sort of fall again, like a stock market. Shares and prices kind of slowly rising, falling, rising, and then slowly falling, kind of like a bounce effect. That dead cat bounce is what it's referred to in the stock market analysis. And here it's just the strength of the frequency within the phoneme is just dissipating. That's what that is. All right, so I just want to kind of finish up on this. I don't want to spend too long on this video, but covering the questions that you have to answer here. It's not just a case of throwing in some documents. It's certainly not just a case of taking screenshots and throwing them in. Annotate your screenshots. Very important to annotate your screenshots. Very good practice. It's in a table, so we don't have to say figure A, figure B, figure C. We've already got it there. You've indicated at the beginning some definitions of who these subjects are, and I doubt you'll be really taking children, but you can share your own information yourselves. You can give each other your own readings and screenshots, with a partner that you would have worked with either in the lab or otherwise. So just some analysis here. Patterns and formats. I mean, you need to write a paragraph of some kind here, but yes, you're getting a paragraph. Why? Because we can see your paragraph would read, look, have a look at that table. You can see you are getting formants roughly at the kind of the 150 to 200 hertz range, and then you're getting another formant at the range of 600 to 700 range. Every time this "a" is said, in particular in this kind of Dublin accent, you're getting the sort of formants in that general range. So 650 hertz up down to 750 hertz. Okay, so what I'm going to do is do an additional test right now, and I suggest you do the same once you've got the pattern. Remember, we're not doing this to make like the fingerprint circumvention just to make Play-Doh and PVA glue. you're doing that to understand how these features work and how these features are the architecture of these features. So let's do the same here and look at the architecture of these particular features of the readings we just got. So we did see a pattern there. It's a very clear pattern that we're expecting something like this. So all of those politicians had the same speech. The synthesized voice had the similar pattern. So when I do that again, I just need to say the word had, and I would be expecting some type of a formant at the 150 to 200 hertz range and the 650 to 750 hertz range. So let me just double check the time there for recordings before we finish up, and I'll record that now once more. I'll do another one. I'll just say had, she just had. I don't even have to say much more than that. Okay. She just had. Stop. Play it back. She just had. Okay, I said that had a bit long and drawn out, not like I did before, but that's all right. So here it is here. Okay, you can see that in the waveform view, waveform DB. Pull it down again. You can take recordings from speeches online or the internet, wherever you want. This is one of the beauties now of voice. You don't need to have tons of people around you and to do the readings. You saw me just swipe Donald Trump's debate with Joe Biden and Leo Varadkar's famous COVID speech there. Okay, so this is me again saying had, the A of had. I'll look at it as a spectrum view, very clear, very easy set of phonemes. You can see them there. The formants are there. And I'll analyze that plot spectrum, and there we go. We get the same picture once again. We get something in the 150 to 200 range, and we get another formant up here. It's now as far as 800, maybe because I drew the had out there. I kind of said had. You're getting that up there in that sort of 750 range and higher. And you can see there's the first formant building up to reach its peak. It dies down, and then the next formant builds up and sort of dissipates down again. All right, so there you go. That's how you do it. Be sure you're using the log frequency. And when it comes to doing your write-up, make sure you do an additional test. Don't just kind of throw in some screenshots and say, here you go, here's my screenshots. It's not because I want a particular thing. It's because that is the academic style. That's how you write an academic document. You don't just throw in a picture and expect the reader to sort of figure it out. I mean, the reader hasn't even got the cursor to see those things. The reader is not going to take out their ruler and start lining them up and say, it is, people sometimes write, it is obvious in their thesis. And, the readers are thinking, well, not to me. So when you put a little annotation in there, then it becomes obvious where it is. You might even pinpoint that annotation if you wanted to, like I've done in this situation with the lines. All right. So put those in there, put down the numbers, see if there's a pattern, and then do an additional test. Okay. Finally, there's some questions to answer. I'm not going to answer those questions. You write a paragraph of what you learned from your analysis. Be sure to use the correct phonetic alphabet terms. Don't just kind of say this is the A of had, because that's an English language term. Use the phonetic alphabet. You can look it up in the notes. They're available on Moodle for you to see. And the lecture notes are there on Moodle for you to just download it and see that phonetic alphabet. Okay, so there we go. The questions are, were the formants uttered by the same person in similar values? Well, yes, we used Leo Varadkar, I used Donald Trump and myself. Were they uttered by two different people in similar values? Well, yes, and why? Don't just kind of answer yes to that. Answer yes and why. In what cases were the formants similar age, gender? Well, I guess we're all pretty much the same gender there, except for the thing. Well, hopefully I'm not as old as Donald Trump, but Leo Varadkar, adult male, and all that stuff. That's fine. Okay, so how can you tell for certain that this synthetically spoken phrase is not a human speaking? Show an annotated screenshot to support your answer. Well, that'll be very easy to show, because all you got to do is go and take a screenshot of the the actual picture. Excuse me, with none of those. You can see, look at, there's no harmonics. It's not a continuous picture. Look at the amount of gaps in that. And that's even a pretty decent one. Is that me?
She just had.
Okay, well, that's my one there. So finally then to the questions that you're going to have to answer at the end of that additional test that you've done. just be sure you do the an additional test to make sure that the numbers work out well. So answer the following questions. Were the formants uttered by the same person in similar values? Don't just say yes or no. Indicate why that is the case. Were the formants of a phoneme uttered by two different people in similar values? Well, yes. You found them online. You recorded each other and shared the results. So in what cases were they similar ages? Presumably for all of you and your classmates, it's the same. So adult, male, Dublin region, etc. Okay, so that should be all right. That's fine. Unless there's any extreme differences, but there's no children. And if you're working with a male voice and a female voice, indicate that. And indicate that whether that got shown in the formants that you did there. So you could even see there, in my case, the accent between the two Dublin accents, my accent and subject A's accent, had similar formants, and the New York accent came out subtly different. Okay. And let's see then. So how can you tell for certain? Well, you're looking for the well, first of all, you can see it's obvious when you look at it. When you look at a synthesized voice, you're trying to look for the lack of harmonics, but there's more to it than that. It's not just the simple gaps. If you completely go silent yourself between the voice utterances, you'll tune out the harmonics as well. So that's just one sign. When there's no harmonics available, show a screenshot like it asks you to support your answer. Another way is that the numbers are a bit too predictable. When the numbers are just too predictable all the time, every time that synthesized voice says something, it's like it's too obvious. It's just too much. They're just using exactly the same numbers every time. So which, in your opinion, would be more straightforward to implement? That's like a speech-to-text generation. So like if I was to speak and this would write automatically on the screen, think about that. Is that an easy thing to do? We'll be talking about that in the next lecture. Okay. Text-to-speech. Could you generate that easier if you know the formats? Biometric identification. Would that be even easier than the two of those? That's a question for you to think about, and I'd expect a little paragraph of a few lines as to why you're supporting your answer. Okay, so upload a PDF only. And that's pretty much it. So a decent document, mainly for yourself and for your reader to really see everything annotated clearly. Okay, so that's lab 4 done, and we'll be doing lab 4. Lab 5 will be a little bit more on that, where we use actual biometric recognition system.